Right, we'll start a little bit early because I was a bit more effective than I thought I was going to be. Good evening, ladies and gentlemen. Welcome to the University of the West of England. Our first speaker tonight is Dr. Catherine Hobbs.
Great, well, thank you very much for the welcome. Welcome to everybody here tonight. It's fantastic to see you all, friends and family, faculty, staff, project team members, fellow students, and people from South Gloucestershire and various places around it. It's great to welcome you here today to the launch of the UWE Racing Class 1 entry. This is a great moment. It's been a long time coming, so I'm very pleased to be here to introduce things today. The Department of Engineering, Design and Maths is the main department where most of our team members come from. Not all, I know, you're from a variety of departments, but essentially we feel that it's the UWE Racing and Formula student team have a base here in the Engineering and Maths department. And the department really values the efforts that the team have made and the work that's gone in over the last 3 years. We value that to the extent that we put some money into the project. We've been putting money into funding their entry to Formula Student for the last 3 years, the last 2 years, and again this year for Class 1 entry. And we also fund the team to go to Silverstone every year and to travel by minibus and camp in the lovely campsite there. Another thing we do is that we fund a faculty advisor. So we have an academic member of staff, Dr. Rohitha Weerasinghe, who will be speaking to us later on. And he is funded to support the team and work with them to help them with the project, both on the engineering side and also mentoring them as a project team. And he himself has been a judge and Formula student, so has some experience of what the judges will be looking for, which is very useful to us. And we also support the team by space and equipment. We provide a space for them to put their car together and to use the computer facilities and the software that we have available in the department. So we're very pleased to be able to do that. And of course, in return for that, we get a lot back. One of the key things we get back, of course, is the raising the skills of our project team here today. So the project team, which currently is, I think there are actually 70 members of the team, is that correct? It's grown hugely over the last few years. I think we were 15 members last year. All the members of the team get to participate in the project. They gain lots of employability skills like project management, teamwork, marketing skills, very important, as well as, of course, the solid engineering skills that they get from working on the project itself, which they'll tell you more about later on. So that's extremely useful for us. We pride ourselves in providing our students with learning opportunities to get real hands-on experience, and Formula Student is a real example where they can do that. Another way that we get return from our investment is, of course, through marketing, in terms of marketing the courses in the department. So the team have been very active on social media, which is fantastic, tweeting, and they've got a Facebook page, which I urge you to join into after today. And also they do a very valuable work at our open days. So when we have open days for students thinking about coming to UWE, the Formula student team pitch up. They often have a working afternoon, I've noticed, on the day in the engine shed, as it were, and they also then will present to visiting applicants and their parents and tell them about the team and how they've got involved in the team and what it's done for them in terms of their education. So we really value that, and I thank you very much for the effort that you've put in over the last 3 years to do that. I've been here at the University of West of England myself 3 years. I came from Oxford Brookes University, which has a very well-developed Formula student team, as you may well know, and takes Formula student as part of the curriculum. So only students doing automotive engineering or motorsport engineering are engaged in Formula student at Oxford Brookes. Here at UWE, what I'm delighted about is the way the team encompasses all disciplines. So we have many team members from motorsport engineering and mechanical engineering, but also from a range of other disciplines, including maths, psychology, marketing, law. Have I missed any? Geography, well done. Yeah. So it's a fantastic opportunity for them to work together as a team. In life, when they go out into a job later on, they will be working in multidisciplinary teams, and it's really effective, I think, for them to get that experience working together with people, different disciplines. You have to explain an engineering concept to a marketing student or to a law student. I think that's a very valuable opportunity for you. So I really think that the approach that UWE's taken to supporting Formula Student as an extracurricular club activity has a huge amount of benefit for the team and also for the department. What's really great to have seen over the last 3 years is the development of the team. I'm sure we'll hear about it later on today, but 2 years ago, well, perhaps 3 years ago, the team weren't in a position to actually enter Formula Student. They wanted to do it, they had ideas, but they weren't really ready for it. For 2 years in a row now, they've entered the Class 2 of Formula Student, which we will hear more about what that means in detail. But essentially, they do a design exercise, they present their work at Silverstone, but they didn't have a fully functioning car. They didn't actually drive around the circuit. A lot of the competition in Formula Student is around your design skills, your presentation, your business planning. That's very important, and that's what you get points for. And I'm really delighted that the team have been recognised for that over their 2 years of entering. So the first year they entered, they came 10th out of 20 competitors, which is pretty good for the first time. And then second time last year came 8th out of 25. So there was sort of an improvement, but also an improvement within a larger group, which is fantastic. And so this year, for the first time, going for Class 1 entry, which will mean a real car. It has to actually go, try and get it round the circuit, and that will be an achievement in itself. I'm sure we'll achieve that. There are 130 competitors from all over the world competing in this competition. It's a big deal. I hope we come better than 130th, but even if we don't, I think it's a fantastic achievement to have got to that point, and it's onwards and upwards for the team, really. So I'm going to finish here and go on to the next speaker. I just want to say very big support from the department, very big thanks to the team. Thank you all for coming today to witness this great event of the launch of the Class 1 entry. I hope you have a good evening and find out a lot more about Formula Student from the various speakers we have and about our team, and see for yourself the great team that we have and the skills that they're gaining from being involved in this project. We're really delighted as a department to support this activity. Thank you.
Our next speaker this evening is Dr. John Lanham.
Okay, thank you. I've asked to come along and just share some thoughts. I suppose a little bit building and echoing what Catherine said about the importance of this. As many of you know, we as a university are heavily involved in the Bloodhound project, and I suppose for my sins, I'm partly responsible for the university's linkage with that. We met Richard Noble a number of years ago. He was looking for a place to build his team and so forth, so we partnered with him, and the rest, as they say, is history, and we as a university sponsor that. So it's great to see this activity. It's the faculty's Bloodhound, probably not quite as fast, hopefully not quite as expensive, but it brings out a number of the key points. And again, as Catherine said, it's about bringing together all of the skills, the stuff we teach them in the classroom, and then also the other things that you pick up through working with each other. All those tussles that you have about trying to resolve and agree points about what the right answer is and so forth. That's a very important skill. Dealing with the ambiguity, there isn't a right answer, you have to work that out. So this is a really important activity. And also it gives scope for innovation, not just technical innovation. And again, as Catherine said, the whole point about Formula Student, yes, it is a part about getting a car to run around a circuit, but actually that's the tip of the iceberg. The real skills that you're developing are the work that goes on underneath to actually enable you to get a car to Silverstone, and all the project coordination, the management and so forth that you need to do. And innovation is not just about the technical innovation, it's also about creative resourcing and provision of parts and so forth. And again, I think you've been down talking to Bloodhound, and I'm sure you'll get some good ideas from them, because they are the arch blaggers. Believe me, they can get anything out of anybody, and have done on many a basis. So if you can pick up some skills from there, you're doing well. So again, it's a real excitement of the fun of the challenge, the competition. There's nothing like a good bit of competition to move people forward and get people engaged. So again, this is really exciting, as Catherine said, to see the team moving to this point. Also, as we look forward to next year, we've got bike engine for this year, but I know the plans are to go electric, slightly greener next year, and that's a really interesting and fresh set of challenges as well there. So it'd be good to see that moving forward. And I think, just thank you for those that are coming along to support the team. As Catherine said, the faculty department have put a number of sources of funding in over the years. I foolishly said I would also support them, but I've set them a challenge in that I will match the funding that they raise through sponsorship. So just be careful. They're here in their smart tops, etc., to try and get money out of you. Make them work hard for it, because that's what's going to happen in the real world. But also, as I say, I'm prepared to match their efforts. So for every pound, to a limit, to every pound they raise, we will support them. Okay, because as Catherine said, this is important as a benefit to the faculty and the department in a number of different ways. And it's great to see this coming through. And also, it's about having fun. Now, I'm not saying that the lectures aren't fun, and the colleagues sitting here who deliver the lecture, I'm sure all of their lectures keep everybody on the edge of their seats, riveted and so forth. But actually, at the end of the day, it's about putting something together that rolls out of the door, moves, flies, or whatever it is. That's what we as engineers are about. We're about creating things out of ideas and so forth. And that's about having fun. That's what I say. It's good on competition. It pulls people, it pushes people. But at the end of the day, it's about having some fun. So hopefully you'll do that. And like others, look forward to seeing you, as Catherine said, hopefully a little bit further up the table than the 130th. But hey, someone's got to be there, and you've got to start. And wherever, and one advantage of there is that it will only be upwards in the future. But I'm sure you'll do better than that. Given the track record you've achieved in the past, we'll see a good, strong performance, and really want to get behind you and support you in that. Have some fun, learn some stuff as you go by, and yes, we're here to support you. But as I say, be warned, people, these people are out after your money. Okay, well, thank you.
Right, our next speaker has come all the way from London in the Institute of Mechanical Engineers, and he is George Hopkins, who's going to talk more widely about the Formula Student event.
Good evening, ladies and gentlemen. The idea of this presentation is to try and give you a bit of background to Formula Student. A lot of people might be involved with the boys and girls here, but it's sort of more about what the competition is, where it's come from, what it's trying to achieve. So there's a few things that we're going to go through here. I haven't actually come all the way from London. I'll confess this, I've only come about 5 minutes up the road. Sorry about that, I should have mentioned that before we started.
You've been to London?
I've been to London before, yes. I'll go through this a bit more in a minute. Formula Student predominantly is made up of volunteers. The huge amount of it, all of the people that support it. We're talking actually, one of the people here from UWE has been a judge. So I myself was involved in a Formula Student team at Swansea University in 2004, and then have been a volunteer from 2005 to present. And actually I'm engineering manager at Hobbs Technologies, which is only just around the corner. So I'm an ambassador for the IMechE, and they asked me to come along to events like this in the Southwest region. So what is Formula Student? The easiest way of describing it is it starts here, to my left, and what you see here is exactly what they get. Absolutely nothing. They get a great big fat space on the floor and nothing else. And all effectively they get is a book of rules. And from that they have to build something, as you can see in the middle picture up there, a full functioning working race car from not a lot. And they have to do that all themselves. They do have a faculty advisor. That's the idea of that is more a point of contact within the university. The idea is that the students do all of the work themselves and create the entire team and the car and everything else around it. From that, you'll get to what we've spoken about already today, the sort of Class 2 entry and some of the parts that you've seen out there, and eventually all the way through to a functioning car at the competition. History of Formula Student. So it started off as Formula SAE over in the States in 1981, so it's been going quite some time. Up until about 1998 was the first year it came to the UK. And it was based at the NEC in Birmingham. 2006, Ross Brawn, I'm sure we all know from Formula 1, became a patron of Formula Student UK. And in 2007 it moved down to the Silverstone, the international circuit, and has been based there ever since. Quick few things about the classes. What we call Class 2 is the conceptual, what I call sort of part build entry. So you can come along with parts that you've made. You can exhibit designs and a bit of a presentation around that, where obviously we've seen the UWE team have done extremely well. The main running event is the Class 1s, which are all of the fully functional running race cars. On top of that, in 2008, Class 1A was introduced, which was for low carbon vehicles. We did see some interesting things sort of appear with hydrogen tanks and all this kind of stuff on it. Really, that's been funneled down the route of hybrids and electrical vehicles. We're seeing a lot of those come up recently. They have become more and more competitive to the point where in 2012 they were amalgamated with Class 1A. So now internal combustion engines and electric vehicles race side by side on equal ground. And in fact, in this year, 2013, the event was actually won by an electric vehicle. Slightly disappointingly for me, but I quite like a bit of a petrol head. So, really centering around Class 1, what happens at the competition? Load of hard work, they turn up with a race car. It is split in half, the event. There are static and dynamic events, so it's not all about building something and racing it around. You have to present a number of things. So you can see a little bit there, split dynamic and static, and also some scrutineering. So, starting off with statics, design event. At the competition, a group of industry judges, so from an industry background that are very carefully put together, will scrutinise their approach to how they have designed it. They'll look at the methodologies, the decision matrices, how they have ended up with the car that is in front of the judges. Some good ideas, bad ideas. Having some super high-tech carbon fibre car isn't necessarily the way forward. It's all about the skills that you have and how you approach the problem. Cost event. As you all know, it's not all about building something fancy. It has to be cost-effective. The model behind Formula Student is basically that you are producing a prototype for a low-volume manufacturer of a race car for Club Motorsport. There's a sort of methodology around it. So how much is the car going to cost? So as a team, they'll be putting together all the costs, as we were talking about how much it costs to build it, to develop it, all of this kind of stuff, and package that up. And again, that will be presented and assessed. And some of your approach to how you've manufactured the car. Last but not least, business presentation. There's no car there for this, a couple of people. Again, very real world, presenting your business case. I would like some cash to go and develop my car. That's why. Business model, business plan, so on and so forth. Something that isn't scored at the competition, which I think is a bit harsh, is scrutineering. So, as I said, they get nothing on the floor except a great big book of rules, and they have to design a car that meets the rules. This is one of the principal things that I do at the competition, is looking at, does it meet it? As you can see from that photo, there's quite a lot of stuff going on. Fuel tanks, breather systems, nuts, bolts, wheels, tyres, you name it, we look at all of it and make sure. This is probably one of the key things. It's about being safe and being fair. So it ensures that all the cars are safe, reduce as much of the risk as we can as an event organiser. Also make sure that all the cars are on as level a playing field as we can get. There's some fun involved in this. You can see here a tilt test. So you strap a driver into the car and tilt the car all the way up to about 60 degrees. And it can't fall over. It is strapped in. If you look carefully, there is a strap off the roll group in case it does tip. And it can't spill fuel. So there's a number of scrutineering tests we go through to really rigorously make sure that the cars are safe before we put them out on the track. Then, the dynamic events. I like this photo. It's a very British photo, isn't it? Brunel University getting very, very soggy about 2 years ago when it was raining quite a lot. So dynamic events are split down into a number of competitions to really test how the car performs. An acceleration event, drag strip, very simple, straight line, how fast can you get to the end of it. Figure of 8, which is called the skid pan, how fast can you go around a corner, again, as simple as that. A sprint event, which is a very small track, a bit like a go-kart track, think of it that way. 1 lap, how fast will the car go on a lap, handling around corners and all the rest of it. The final event is the endurance event. That is the tricky one, I warn you now. Just like the sprint event, it's a great big track and you go round it and round for about 20 to 25 laps. And that's really, clues in the title, it's the endurance event. That's where cars tend to sort of overheat, fall apart, disintegrate. And it's really testing whether or not they've made something. Great, it goes quick. Will it actually last 22 laps? So, as a whole, Formula Student, far more than just a competition. It's live engineering. It's fantastic what the universities teach people, but it's about applying it. And in the industry, I'm sure there's people here, I'm employing some as a manager, or getting people in. People with a former student background have a much wider grasp of the application of what they've been taught. Well, originally what they were being taught in university. They now have an opportunity while they're learning that to apply it. Volunteers, as I said, if people are interested in getting involved, you can contact the IMechE through the website. It's fantastic fun. I would encourage anybody that's taking part now to get involved after they finish. University, as we're seeing, is great publicity for them, and businesses, both advertising, partnership. At the competition, you can see a lot of the cars are going to stick it. It's a good advertising tool. It advertises university, and it gives it really another string to its bow to encourage students to come to the uni. So that's about it. 2014 competition is at Silverstone. Typically you get around 100 vehicles at the event. It can go up and down from around 30 different countries. So it really is an international event. We see people from as far afield as India, Australia, all over the place. And it's now in its 16th year. So I'd encourage anybody that's interested in this, that's supporting the team. It's not just them that can go to the competition. Anybody, jump on the IMechE website, come and have a look. It's fantastic fun. It's really interesting to see who they're up against and how well they do. I will now hand you back to Abbie. Thank you.
Okay, hi everyone. I'm Abbie Grange. I'm a third year motorsport engineering student here at UWE, and I'm the deputy team manager of UWE Racing. Firstly, I'd really like to welcome you all to our very first launch event, first one we've ever done. We are really flattered that you've all taken time out of your busy schedules to come and hear what we're doing. We really, really appreciate it. Okay, so UWE Racing. We have successfully competed as a Class 2 entry in the last two Formula Student events. In 2012, we were the highest placed Class 2 entry that didn't also enter a Class 1 vehicle. 2013, we were the most improved Class 2 entry overall, which is a real credit to the team. This proven track record of constant progression will be further accelerated this year by the fact we started the year with 5 people that carried forward from last year. We now have 70, and they come back every week. We now have a dedicated business team of around 15 people. They divide their time between social media profiling, marketing, costing, project planning and graphic design. This is the first year UWE Racing has ever had a dedicated business team that spends all their time running the lesser known aspects of UWE Racing. The design and engineering team has also expanded to over 55 members. This drastic increase in numbers has allowed for the completion of design tasks to happen much quicker. We can also identify and correct problems as and when they arise, as we have the manpower to do it. All in all, the capabilities of the design team has increased literally tenfold. This means it puts us in a really good place to get a really decent Class 1 entry into Silverstone this year and really represent our university. Alright, I'd now like to pass you over to Callum, who is our team manager. He's going to take you through the designs that we've worked on over the last few months and what we brought forward from last year. Thank you very much.
Hi there, I'm Callum, Lindsay, team manager here at UWE Racing and a third year motorsport engineering student. Again, I'd like to welcome you all tonight. It really does mean a lot to the team to generate such interest in the smaller companies, the public and the larger companies over the last few months. It really does put into perspective the team's effort. I joined the team my first year at university and instantly found myself thrown into the deep end, having to design uprights with dimensions I was given. Before I came to university, I didn't have a clue what was involved in the design of an upright and what design characteristics I needed to include in that. The car itself was a bare model, as you can see. It had the basics of the car factored into it, but it lacked a lot of performance characteristics, and when it comes to the chassis design, the suspension design, the packaging of the ancillaries, and of course how the chassis reacted to certain inputs from the driver. This was UWE's first year as a former student team, so we had a lot to learn in how the former student competition worked and how to design a winning car. Over the past 2 years, the design has been drastically changed, with redesigns of the chassis constantly being scheduled last year to make sure we met all the FSAE regulations in terms of packaging of the powertrain, suspension, ancillaries, electrical, and to make sure the chassis met all the regulations with its clearance boards and crash zones on it. The team also discovered neat little ways in order to increase the car's adjustability. This allows us to put a driver in it and we can tune the car to exactly what that driver wants in terms of camber, tone, performance characteristics in the engine, we are able to run 5 or 6 different fuel maps on our ECU. The team, as Abbie said earlier, in our first year we came 10th. Up at that, the judges gave us a lot of design feedback, and we really grew on that over the past year, placing 8th out of 25 teams, which is something the team and the university is really proud of. This year we're well on track for running car, mid-April, ready for about 2 months testing. The chassis team have already started manufacturing most of their components, hopefully rolling out a rolling chassis in the next couple of weeks. The powertrain team and the electrics team have also been working very closely. Obviously, we had a carburetted engine donated to us 3 years ago. This had to be converted into fuel injection in order for us to run the different fuel maps. So we've had to make our own inlet system, our own custom wiring loom, and of course map our own ECU. Unlike many other Class 1 teams, UWE Racing is not part of the engineering course. This allows us to take, as Catherine said earlier, any students from anywhere in the university. I think this year we've incorporated every single different faculty from the university with somewhere in the team, whether it be from law school, business school, marketing school, somewhere in there in the team, whether it be design or business, there's a student from every single faculty. It isn't just for engineers. Anyone with motivation and the time, we're more than happy for them to be there, and we're more than happy to give them the training they need in order to step up. UWE Racing is a constantly evolving team. Obviously, when we graduate in our 3 years, we don't want the team to die out. We take them on from their first year, give them the necessary training they need, so in the second year they can take a more team leader role. We then take a step back, and they lead the team, and then as we graduate, they come into their 3rd year and they're more than ready to carry on at the same speed we left off. I'd like to welcome my design team to the stage to talk you through this year's current design status and how far we've come over the past couple of months.
Hi there, I'm Josh. I'm a 3rd year motorsport engineering student here at UWE, and I'm the manager for the chassis team here at UWE Racing. I currently have a number of students on my team from motorsport and mechanical engineering awards from all years of study. As the chassis team, our main concern is of course the chassis, which we're tasked with designing and manufacturing. It's important when we make this, as you've heard, there's a lot of regulations for us to meet, so it's very important that we meet all of these properly. They largely dictate the placement of much of the structure and most of the material properties, so it largely determines the shape and characteristics of the chassis. Our current chassis was made last year and taken to the Silverstone event as part of the Class 2 submission. It was designed in SolidWorks in accordance with our requirements, just making sure that it would still adhere to all the regulations. It was then tested with some finite element analysis software to make sure that all the stresses and loads through the structure would make sure that it would not fail when we took it out or when it eventually goes out onto the track. To perform almost anything effectively to do with chassis design, it's important to have a knowledge of both CAD and of finite element analysis software. So the students on my team, the less experienced ones, have been helped along in this respect. We've been helping to teach them so that when it comes to later on in their degree, they'll sort of get a head start, as it were, so they'll gain an advantage over their teammates in this respect. With the chassis mostly completed last year, we're currently working on the placement of the harness bars, which are important to attach the driver's harnesses to. It's important that they don't introduce any extra stresses in the system, so that's what we're currently working on. We also deal with some of the less critical but still important parts, such as the chassis floor, which is important to protect the driver from any debris that are on the track. We're currently manufacturing this and hope to have it completed before Christmas. Once all of these have been completed, we're going to be moving on to designing and eventually manufacturing the chassis for the 2015 event. It will involve a number of differences, as this vehicle is going to be driven by electricity rather than petrol driven. We're investigating a number of aspects of the current chassis and seeing how they transfer to having an electric powertrain, and we will hope to identify any areas for improvement. That concludes the chassis section. I will now hand you over to our suspension team.
Hello everybody, my name is Oliver Garston. I am currently the suspension team leader. I'm also in my third year studying motorsport engineering at uni. This year the suspension team is growing to around 10 members. From the start of this year the team has dived straight in with a quick 2-week CAD crash tutorial to get everybody up to the same scratch and on the same level. Once this was done we started reviewing the work left over from last year's team, making sure everything that we had worked. Once this was done we started looking at extra things we needed for this year's car, and effort was put into effort was put into designing final bits for this year's car so we can have a rolling chassis in the next couple of weeks. So the workload is going to be slowly stepping up over this time. The manufacturing of the main suspension components has begun, with wishbones, uprights, hubs, spindles all having been started, with bell cranks needing a few tweaks before their manufacturing can begin. Our shock absorbers were kindly donated to us and custom made by Protec for a great price, and these can be mounted inboard using bell cranks and push rods to connect to the lower wishbones. After the Christmas period, hopefully we'll have brake discs manufactured and wheel with brake calipers purchased as well. Wheels have been chosen, and again these will be purchased after Christmas. Tyres are still being investigated, but a decision should be made on them soon. We're currently looking at a Titan steering rack as well, although we need final measurements to be complete before this can be purchased as well. Once the suspension system has been fitted to the car, their attention will turn to next year's design and testing on the complete car for the Formula Student event in July. And now I'll pass you over to capable hands of Adam for head of the powertrain.
Hello and good evening. My name is Adam Laver and I'm in my final year BEng Motorsport Engineering here at UWE. My role within UWE Racing is the powertrain team leader for this year. We are one of the largest sub-teams in UWE Racing. We range from first years up to master's level students, all studying engineering. And as a team we are responsible for the main running gear of the car and its performance. Our main challenge this year is the electronic fuel injection conversion of our previously carburetted Yamaha R6 engine that you can see on display outside. After the conversion is complete, we will be able to begin testing the engine for performance values under Formula Student regulations. We hope to start this testing before we break up for Christmas. For the ECU, we're using a microsquirt V3, which will allow us to have much greater control over the engine's power production than the previous carburetors, with also a significant saving in weight. By regulations, we will have to run custom fuel maps for the ECU. To do this, we will use a program called Tuner Studio, and we will create at least 5 custom fuel maps, one to test the engine under safe parameters, and then one each for each of the dynamic events at Silverstone, so the sprint, the skid pan, autocross, and endurance and efficiency. Our final drive unit is a chain-driven Quaife differential with a 3.5:1 sprocket ratio. The Formula Student regulations dictate that we must use a 19mm restrictor on the air intake. Our current design incorporates a dedicated Formula Student air intake incorporating the throttle body from AT Power, which incorporates this restriction. We are currently in the process of manufacturing our dry sump, and I've made a 3D prototype using our in-house additive layer manufacturing machine. We were looking to outsource CNC manufacture to a specialist company. The exhaust has been designed by a former team member last year as part of his final year project, and is the best design for exhaust gas flow in the space limitations we have for the chassis. This flow analysis was kindly done by Ricardo as some sponsorship. As a design team, we have to make sure we work closely with all the other design teams to make sure none of our designs conflict with any of theirs. I will now pass you over to the ancillaries team.
Good evening, I'm Darren Bateman. I'm in my 4th and final year of the MEng Motorsport Engineering degree here at the University of the West of England, and I'm team leader for the ancillary sub-team at UWE Racing. The ancillaries team is responsible for all the aspects of the car that do not come under any of the categories covered by the other sub-teams. The ancillaries team itself is quite diverse, although it is the smallest of the design sub-teams at UWE Racing. We have a mixture of students from a number of different mechanical engineering disciplines, all at different stages of their studies at university. Aspects of the car that come under the ancillaries bracket are key safety features of the car, as well as other components that are vital for the operation. The safety features the ancillaries team are responsible for include the firewall, the impact attenuator, the driver's harness and seat, and the fire suppression systems for the car and the garage. The driver will sit in a reclined seating position to keep the centre of gravity of the car as low as possible. We are currently working on the design of the seat to accommodate this reclined driving position. A 6-point single-seated racing harness will be used to secure the driver safely, and the seat itself must be supported by the chassis, as it cannot be resting on the firewall, which is directly behind and underneath the seat. We will use the official Formula Student Certified Impact Attenuator at the front of the chassis due to the financial advantages of doing this over designing, testing and certifying our own impact attenuator design. The other components of the car that the ancillaries team are responsible for are the paddle box and the fuel tank. The fuel tank will be located in the space underneath the firewall and the seat, and will require a capacity of at least 10 litres to allow the car to complete the endurance event at Silverstone, as well as internal baffles necessary to control the flow of the fuel inside the tank. We're currently working on modifying the existing pedal box design to allow the brake bias to be altered between the front and the rear tyres. We are also working on modifying the design of the pedals themselves. The pedal box design already allows for the pedal box itself to be moved inside the chassis to accommodate drivers of different heights. This is necessary as the seat is stationary. We plan to design work for the ancillaries completed by Christmas so we can focus on assembly and manufacture in the new year. Now I'd like to hand you over to our aerodynamics team leader.
Hello, my name is Andrew Adams. I am the aerodynamics team leader for UWE Racing. My role in the team is to design, test, manufacture and fit the bodywork for the chassis. I have a small team of students from this university from various courses and various stages of their degree. Currently we have a CAD model set up of the car. Our next stage will be to test it. One way we'll test it is to use a program called ANSYS to run a CFD test on it. Another method we will use is to put it through a wind tunnel. For this we'll have to have models made. Once it's completed, we'll be able to see any flaws in the bodywork and have them adjusted just to make the bodywork more efficient. Once this happens, we can begin manufacturing. For that to happen, we have to have a mould made, but we're looking to have this outsourced. Once that is completed, we can actually start building the actual bodywork. For that, we're going to use fiberglass and do that in university, but we are open to ideas if you have any. So upon that being complete, we will have to fit the bodywork, and do that we plan to use quarter-turn fasteners. We aim to have this done by the end of March, so the team has enough sufficient time to test the car as a whole. I'd like to pass you on to the electronics team leader.
Hi, my name's Tom. I'm a first year business entrepreneurship student and I'm actually filling in for our head of electronics team, who unfortunately can't be with us today. Team Electronics is responsible for the research and development of the wiring and electronic systems of the racing car. Our main objectives are to develop the engine wiring system, research and develop the digital gauge system, and to adapt and maintain all onboard electric and electronic components in accordance with the Formula Student regulations. Well, in order to make our engine start and operate, we have to convert the Yamaha R6 carburetor fueling system into a fuel injection system that will be controlled by a microscope programmable engine management system. The conversion process is undertaken in collaboration with the powertrain team. In this process, our responsibility is to develop and adapt a new wiring loom for the engine. Another task that we're dealing with is the design and development of a digital gauge system that will display the engine operational data on an LCD display, a 7-segment display, and an LED gauge. The system is going to be based on a programmable PIC microcontroller development board. That's a real mouthful. The system will display parameters such as coolant temperature, oil temperature and pressure, engine rotational speed, and the gear that's selected on the sequential gearbox in the car. At the moment, we're working hard on the development of the wiring loom, and we're planning to test... Oh no, that's not right, sorry. We're planning to run our first engine test in the beginning of December 2013. Our next major step will be the development of the digital gauge system that I talked about earlier, and this has to be ready by February 2014. I'll now hand you over to our project management representative. Thank you.
Hi there, my name is Tom Latimer. I'm currently in my 3rd year studying aerospace engineering, and it's my role within the team to create a comprehensive project plan for the team to stick to throughout the year. I've spoken to each individual team leader. We've made the Gantt chart that you can see here, so that every week I liaise with them and check that they're sticking to task and making sure we're going to get the car built on time. And also, we can change the plan necessary due to the schedule constantly evolving. As you've heard from all the design team leaders tonight, there are many key dates we have to stick to throughout the year. The suspension team want a rolling chassis within the next 2 weeks. The electronics and powertrain team want to get the sensors in the engine and the engine on the dyno to run tests by the beginning of December. The chassis team want the floor installed on the 5th of December. The ancillaries team want all their design work completed by Christmas, and the aerodynamics team want to get the bodywork on the car for the end of March. So to ensure this happens, I have to plan out the manufacturing stage as well to make sure we optimise our time in the workshop and have a completed car ready for test on the 29th of April. I'm going to now hand you over to the costing team.
Me again, you lucky people. Right. My name, finally, is Alex Masters, and I'm in charge of all the costing and the team bank account. I'm a master's level student in motorsport engineering, and I've been with the team since my very first year. In that time, I've seen the team come through thick and thin and has gone from strength to strength. And I'm very proud and excited that I can be here just long enough in order to finally see a completed car. The costing process really falls into 2 main categories. There's the actual job of sourcing and purchasing components, and a theoretical aspect that's linked with the business model. In the real world case, accurate price estimations are essential in order for us to construct a valid proposal to put forward to the myriad of engineering companies that we need help from in order to get the job done. As it stands, the estimated current bill for the items we need stands somewhere between £15,500 and just over £18,000, much of which, as you can see, is coming from the suspension and the aerodynamics teams. This is because we already have the engine, which you can see outside, and the chassis, which we're unveiling at some point this evening, which takes a respectable portion out of the cost analysis, but particularly the suspension and the bodywork, we still have a lot to do. For me and my team, making sure that the money is both coming in and going out on time are top priorities this year, as we want to ensure the production of the car is not delayed unnecessarily. The second, the theoretical side of the costing, however, brings an entirely new meaning to the word precise. There is a standardised price sheet that we get from a Formula student that lists every single component that you can possibly use and every single process that you can possibly use to manufacture a motor car. For example, according to the sheet, there is an enormous difference between starting off a nut and a washer with your fingers and then doing it up all the way with a spanner, as opposed to doing it up until it's finger tight and then just tightening it up a little bit with a spanner. There's an enormous difference, apparently. This list, however, including all its many eccentricities, is the only way that we can compare such different racing cars fairly in terms of costs. I'm now going to hand you over to our final student representative, the head of our marketing team. Thank you.
Hi, I'm Kim and I'm a marketing student. I lead up the marketing and sponsorship team. It's a team of 5 people from different degree courses, as we've already heard. The design is split into separate sections, the team split into separate sections such as marketing and sponsorship. It's split up into writing proposals for businesses and grant making trusts. It's PR and communications, And last but not least, the important work that we do with the social media team, who are also here tonight. The work that we do is, to date, we have raised over £800 in cash and £750 in parts. But this is only going to take us so far. In addition to this, the team are running a number of fundraising activities, such as bake sales, cleaning student halls, packing bags in Sainsbury's, so if you see us, do so. As well as the raffle, which we've got going on sale tonight. But in addition to that, we do need sponsorship from companies. As a part of sponsorship, which starts at a mere £250, there's a number of different options available, including things such as having the car made available for your corporate events, having obviously your name and details on the car, on teamwear, as well as being promoted on social media, the local student newspapers, as well as around the campus and any media that we have. Sponsors that we have to date are Buckham Brewery, which came on this week, Zergotech, which will be doing our coatings for our exhaust, Ricardo and Stud Welders, whom everyone's already mentioned, and Protect Shops. But this is by no means an exhaustive roster. There will be more coming on, I'm sure. In addition to the sponsorship aspect, we've also had the sponsors that have kindly donated prizes for our raffle. That includes the Circadian Trust down in Kingswood, who's given 3 months gym membership, 2 family swim vouchers, Radisson Blue, who's done a meal for 2 with wine, down in 2-course meal for 2 with wine, Marriott Hotel, bed and breakfast, amongst many other things. The tickets will be going on sale tonight in the foyer from £1, so please do come and see us. Have a mingle, and we're also going to be unveiling the car as well, so do join us after the event.
Right, my job's a bit redundant now, because as you can see, I'd like to welcome Professor Paul Olomolaiye to the stage, please.
Good evening, everyone, and the only thing I can be tonight is a very proud dean of the faculty with all the students that you have seen. I think that's the only option that I have, because I'm so proud of them. I'm so proud of our students because they are building on a heritage of engineering in our city and in our region. They are building, I can look back and say 120 years ago or 120 years ago, there were no many cars around. Maybe these are the sons and the great-grandchildren of those great-grand engineers 120 years ago trying out cars. And those great-grandfathers of ours, they were able to plant those engineering seeds in the grandfathers. The grandfathers planted it into the fathers. And the fathers have been able to plant that engineering seeds into the enterprising students you have seen tonight. They are building up on a foundation, a heritage, and they are carrying it forward. And my challenge and my assurance tonight is that our students, which you have seen tonight, they will plant it also into the next generation. And I'm so proud of them, and I think we should give them a clap. Who will not be proud of such confident and innovative, creative students? They came from nothing, absolutely nothing, from just maybe one engine that has no life remaining in it. They gathered themselves together, and from 5 to 10, from 10 to 15 students, and from 15 students in one single year, moving into 70 students in the last 12 months. Who will not be proud when you have nothing? You are just with a little engine. The only thing you could do, you couldn't even afford to go to class 1 engine, to go to class 1 racing, because you haven't got a car, you haven't got anything. All you have is a concept and a dream that maybe in 3 years' time, maybe we can get into class 1. And those students gather themselves together. They believe in themselves. They put in a structure that, oh, we will do this, and we are starting a great thing, and what we start will not end in year 3, it will not end in year 4, it will be here forever. You see, I'm so proud of our students because they went first year, they came 10th, second year they came 8th, they now have enough to go to the class 1. They are confident and creative, and they are collaborative and team working. They didn't keep it to themselves. They didn't say that I'm just motorsport engineering, oh, I'm just faculty of engineering. They brought in people from marketing, they brought people from business and entrepreneurship. They brought them together into a team of 70. And the team is obeying instructions from each other and working through that each other themselves. And that is, to me, excellent. So they are collaborative, they are team working, and they are sustainability conscious. They say, well, when I get to year 3, I'll be able to hand it over to somebody in year 2. The person in year 2 will be able to hand it over to somebody in year 3, into year 1. We're going to work with year 1 and year 4. Those in the master's course, all of us will work together. And then when we leave, we'll hand it over to the next generation. And the next generation will hand it over to the next generation. I believe when UWE goes to Silverstone next year, there will be 100 cars. Most likely, UWE will be in the top 50. We are used to being in the top 50. Okay? Now, after being in the top 50, and with this generation strengthening from generation to generation, I can guarantee within 4 or 5 years, UWE will be in the top 10. And our cars will soon be the fastest car in the land because we are the home of Bloodhound. And I'm so proud that Bloodhound is coming here from Bristol. And these are the children of the Bloodhound that is going to take the world by storm. I'm so proud of our students. I was in Doha, in Qatar, and I was trying to sell Bloodhound to them to see whether I can get some of the Qataris to come and sponsor Bloodhound. And it seems it may happen next April. And I can just see something. Maybe there may be a Qatari in the audience tonight, or somebody with a large wad of check. I want you to invest into the most creative, heritage-sustaining, team-building, collaborative student that you can have. I tell companies tonight that you'll be happy and you'll be lucky to have a UWE graduate working for you. And I'm just a proud dean with a big mouth. I want you to know that you can only be proud of the students. I think there are 1 or 2 parents here tonight, and I think you can see what they're doing, and they are doing very, very great work. I'm proud of them, and all I can say is please clap for them.
Well, thank you very much. That was just missing a bit of Nimrod, and it would have been quite beautiful. Right, penultimate speaker this evening, who probably won't be playing Nimrod behind him, is our faculty advisor, Rohitha Weerasinghe.
Thank you, Alex. No, I'm not going to talk much. I'm just going to thank everyone who has helped us make this event a success. First of all, I would like to thank Dr. Catherine Hobbs, our head of department, for all the support she has given in coming to this. And then I would like to thank Dr. John Lanham, who has agreed to fund as well the whole student team and all the support that he has given and the encouragement that he has given through Bloodhound as well. And I would like to thank Professor Olomolaiye, our Executive Dean and Pro Vice Chancellor, for all the encouragement that he is giving to the students and the faculty. And I would also like to thank Mr. George Hopkins, who has come to encourage the students and enlighten us on Formula Student event. And you've given a really good insight into the Formula Student event. We thank you for that. And I would also like to thank you, Mr. Ian Bolt, the Mayor of South Gloucestershire, for coming to this event and supporting us in this event. And I would also like to invite you to unveil our car after I've gone from here. And again, I would like to thank all my staff, fellow staff members who have come to support me and the team. Thank you all for spending your evening here. Last but not least, my team. I thank you all for doing what you have done, and good luck with what you are doing, and I'm sure you will be successful this year. Also, I would like to thank the ladies and gentlemen who have come from the industry for this evening. With that, I would like to invite you to unveil our part-built car and to have some food and drinks with us to celebrate this event. Thank you.